Assalamu alaikum wa rahmatullahi wa barakatuh, and welcome to our online sessions, matric revision sessions with myself, Muhammad Fasih Peterson. Today it's Mathematics Paper 1 once again, our third session in the series, and today we'll be joined by Sandra Dixon once again. We'll be looking at mathematics, algebra, functions and inverse functions, and of course Sandra herself is a BSc she's a BSc from University of Stellenbosch. She tutors in maths grade 8 to 12. Sandra Dixon, once again, welcome. Thank you for joining us.
Thank you very much for the opportunity. Very much appreciated.
It's a pleasure having you with us, ma'am, and we look forward to another, should I say, very constructive session. So without further delay, I'm going to hand over to you. Sandra, take it away.
Thank you very much. Good morning, guys. I'm back again, and it's still paper 1, the algebra section of November 2020. Like with the previous sessions, I will again give tips and hints as far as we go. So I am not just merely going through the question paper, but I do cover the questions as well. So let's get just right in. We're looking at question 4.2. Now, 4.1 was to sketch a hyperbola, which we've already done. And I just stress that they always ask for you guys to sketch one of the 4 functions that we need to know. And the 4 functions are a straight line, a parabola, a hyperbola, and an exponential function. So please, when you do your revision, make sure that you can sketch these graphs. But now question 4.2. We have 2 functions here, fx, and just to give you a second, when you see an equation like this, you need to know what type of a graph it is. If you don't, the little f shows you which graph on the picture in your exam paper it is. So if we look at that little f there, which I'm pointing out now, and we go to the question, it corresponds to the f over there. So if you did not know that this is a parabola, you've got another chance, because you can now see it's a parabola. Now, this formula is in a very special format, which I will deal with in a minute or so. Then we have a second graph, gx. So we look at the g, and we look at the g on our question paper, where I'm pointing at now, and that is a straight line. So for this question, we're dealing with a parabola as well as a straight line. So now they're giving us a hint here. They're telling us A is the turning point of graph F. They also tell us, that's another hint, the axis of symmetry of F intersects the x-axis at E. And the line G at D coordinates M semicolon N. So this is quite an important line which we miss. So you need to understand that any vertical line or a horizontal line, for that matter, has got an equation. So be very careful that this axis of symmetry is a very special line. And it crosses the x-axis, or the x-intercept would be at M. And the x-intercept M here by D would be the same x-intercept here by E. So that would be M2. Then the next hint is C is the y-intercept, another hint, because we know what to do if we see the word y-intercept. So C is the y-intercept of both F and G, and we find C over there. And I will refer to that in general as a cutting point, but it's also a y-intercept at the same time. Now let's go a little bit back over a parabola, because somewhere between grade 10 and 11, you guys miss the formula for the parabola, because I'm dealing with a parabola at the moment. Now, we all know that a parabola stems from a quadratic equation. So any equation that has got a squared in it, if you draw this function, you will get a parabola. But now there are two other ways of dealing with a parabola. And this is important. Now, if we go to the question, you see they talk about a turning point, right? So if they talk about a turning point, we are going to use this formula here. So this one is y equals a, which is a constant, open bracket, x minus p, close bracket, squared, plus q. This you will not necessarily find on the formula sheet. You will find the standard one on the formula sheet. So now if we look at what have they given us, fx is in the turning point format, and you need to study this, memorize it, and recognize it. So if you have a turning point, we use a special formula, which is this one over here. Now, in our example here, a would be a half, and p semicolon q would be the turning point. So in other words, if we just carry on talking about this question, a is a turning point, and the x value would be minus 5, and the y value minus 8, because that is your p and your q. Just a note, the negative comes from solving this part of the equation, because if you set it to 0, x will be minus 5 or negative 5. And then just additional information. If they gave us the x-intercepts, in other words, if we look at our picture on the right, they gave us that coordinate over there and that coordinate. We would use this formula, y equals a, open bracket, x minus x1 and x minus x2. And you should immediately see that if we multiply this out, we will get this equation over here. Right? So all that we will do, if we have the x-intercept here where I'm showing on the graph, we will put it into x1's value, and the one on the right-hand side, we will put into the x2. But this question does not deal with this, so I'm going to basically just walk off it. But please write down this slide and remember then that when you work with a parabola, that there are actually 3 equations that you can use. Right, let's delve further into the question. Now, as I said on the previous slide, APQ is a turning point, and I'm showing you here clearly. The plus 5 becomes a negative 5, and we use the y value minus 8, which is your q value. So A would be minus 5 minus 8. Right? So that is question 4.2.1. And it all hinges around, and I'm going back to understand what this formula tells you. It actually gives you the turning point directly. Question 4.2.2. Now they want the range of f. Now, the companion word for range is domain. So we need to know what is a domain and what is a range. Domain deals with your x values. So in other words, where will your function produce x values? And range with a y. So you need to understand the question. It wants to know where will we find y values in our function f. Now, in plain English, you will find them inside the parabola. So if we now look at our picture on the right-hand side, we have the turning point. I've put it in. It's -5, -8. And where's the inside of this parabola? The inside is over here. That's your inside. And if the parabola was upside down, it would still be from the top part right to the bottom. So if we look here at the bottom, we can clearly see there are no y values corresponding to this function, because this is your y-axis over here. So if we move up and we get to -8, -8, that is your first y value that corresponds with this function. And as I said previously, we will find it inside here. So if we move up your y-axis, you will get y values all the time. Now, a simple way to visually do it is by drawing imaginary lines from your graph to the y-axis. And if we can do from the graph to the y-axis, from the graph to the y-axis, I trust you see what I'm doing, from the graph to the y-axis. So we will get values everywhere up here. So our answer would be y is greater or equal to -8. The equal is there because we include -8 because it actually starts over there. So that is the range of f. As a matter of interest, what would the domain be? So if we again do it visually, x values would be, we would be looking for values on the x-axis. And if we do an imaginary line from the graph to the x-axis, can you see we hit the x-axis? On this side, from the graph to the x-axis, we can do imaginary lines all the way up to there. And then we go above the line and we can do imaginary lines down like that. So in other words, every x value is possible to be the domain. So in other words, x would be an element of real numbers. So I'm just explaining this in addition. If we look at question 4.2.3, now they want the values of m and n. Now this question you get in many flavors. What I've done to our graph, I've inserted the turning point, the -5. So this x value will be the same along this line. Now, very important here, the equation of this line is x equals -5. Can you see that? So any vertical line or a horizontal line has an equation. And note, the y-axis has an equation too. It would be x equals 0. And your x-axis has got an equation too, and that would be y equals 0. So you can see the x's and the y's swap when we do the equations of this of this. Right, so we're looking for DMN. So it's the first thing important. Remember on the previous slide, I said they gave us a hint. They spoke of an axis of symmetry. And I always joke with my learners that we did symmetry in grade 6 already. Remember you had those faces? And you had to tell whether a picture was symmetrical or not. It simply means that you can cut it into two halves. That's a mirror image of each other. That's what symmetry means. So the axis of symmetry for a parabola would cut right through the middle of the parabola. Now D, it's important to see that D is a point on graph G. Very important. And we have a formula for graph G. The formula for graph G is a half x plus 9/2. And this concept, they test any means possible. That if you have an equation and we have one of the values, the x or the y, we can substitute it into the equation and calculate the other value. So in this case, it was important to see that we have the x value, which is -5. So if you have the x value, we use this formula here for the straight line to calculate the y value, which is gx. So all that we do is we take a half, we sub the -5 into the value of the x, plus 9/2. And if you put that into your calculator, you will get 2 as an answer. So your y value is 2. So therefore, m equals -5 and n equals 2. Or D's coordinates would be -5 semicolon 2. So let's just highlight what I just told you. First of all, vertical lines has got an equation. This is a very specific one. It's your axis of symmetry. And the x value is -5. So therefore, m is -5 too. So we need to calculate the y. So we need to see D is a point on graph G, and that is why we substituted the -5 into that formula to obtain the y value. Now this normally throws many learners because you don't expect an area question in your first paper. But please make peace of it. They keep on doing it, where they would put, like in quotations, a paper 2 question into paper 1. So let's see what's going on here. They want to know the area of OCDE. Now it forms a trapezium because we've got two parallel lines, OC and DE. So you could have used the equation for the trapezium straight away and get the answer. It's quite a hard equation to remember, so I decided to do it differently. I've split my picture up into an area A, which is a triangle, and an area B. Remember, this is 90 degrees because the x and the y axis are perpendicular on each other. So now we need two formula. We need the area formula for the triangle and the formula for an area of the rectangle. So the total area would be A plus B. Now A is a right angled triangle. And the question would be the half base times the perpendicular height of that triangle. Now, again, I'm putting this in deliberately because I see many schools only write half BH and that's it. And many textbooks do that too. But please remember what is going on here. This perpendicular means that when we choose the sides, we basically go to the perpendicular part of your triangle and you use the two sides around it. So we are going to use this side and the perpendicular height, that side. So now let's see what have I filled in here. If we want the coordinates of C, because we need the Y value here, and we've calculated that in the previous question. But let's go over it again. To get the Y value here, we would insert the 0 into the straight lines equation. And in your calculator, we will end up with 9/2 for that value over there. This value here is 2 because it's D, and this is a horizontal line, so the Y value would be 2 here as well. That is 0. So let's see, what are we going to do? So if we sub the points, and we're busy with the triangle at the moment, we would do a half. The base would be 5 units, and the perpendicular height would be 9/2 minus 2. In other words, that height over there. And to that, we would add the area of the rectangle, which is length times breadth. And that would just be a 5 units times our 2 units up here. And if we put that into the calculator, we will get 16,25 units squared, because there's no centimeters or meters here. So if that is not the case, we indicate an area as units squared. So I think it's not a difficult question, but you need to know how to find your way around this trapezium to find the correct Y coordinates to actually do the formula. Right. So question 4.2.5. Determine the equation of G to the power -1, which means the inverse. And they actually say G to the -1, comma, the inverse. So they're telling you they want the inverse of G in the form Y equals. So they're also telling you how they want you to write the answer. So let's start. We're talking about function G, so we write it down. Gx equals a half x plus 9/2. Now, Gx means y. So whenever we start working with the equation of a function, we would work with a y and not the Gx, even though they mean exactly the same thing. So y equals half x plus 9/2. Now the rules to do an inverse. The rule is simple. We swap the x and the y. So this you need to study. So you need to study that if they ask for an inverse, and it's that little sign over there, the -1, we do it by first, whatever equation they give you, that you swap the x and the y. So let's do it. So now the y will become an x equals a half y plus 9 over 2. Now, the next thing we need to do, remember they say in the question, we want the subject of this equation to be y. So we will have to work this equation so that y is the subject of the equation once again. Now, a simple algebraic way to do that is to use the LCD because we hate fractions. So we get rid of the fractions first. So the LCD, local common denominator, equals 2. So we will multiply by 2, multiply by 2, multiply by 2. So we'll end up, so I'm stressing here again, you need to understand the algebra workings around a LCD working and getting rid of fractions. So times 2, so we'll end up with having 2x equals times 2 here. We'll get rid of the 2 at the bottom. So it will be y plus 9. We do it times 2 here. Every single term has a times 2. So we end up having 2x equals y plus 9. But we are looking for y. So y would be 2x minus 9. So we take the 9 to the other side. And you will notice that I'm working backwards here. I strongly recommend that if it happens the way it's happening here, work backwards. Because if you swap the y to this side and the x to this side, you tend to get your signs, your negative and your plus signs wrong. So our answer is the inverse of g, that's how you read that. The inverse of the function g is y equals 2x minus 9. So that is an easy 2 marks. I've done a lot of workings here for 2 marks. However, I'm really trying to explain exactly how this is done, because this is in every single paper that grade 12s write at the end of the year. Right, now this one is a level 4 question again. So let's see what they want. If hx equals the inverse of function g plus k, which is a constant. So if this is a tangent to our graph f, determine the coordinates of the point of contact between h and f. So our key words here is that it's a tangent, and we want the coordinates of the point of contact. Now, the point of contact is where the two graphs touch. In this case, they touch, and it's between H and F. So, to approach this question, we need to immediately know when they talk about a tangent, we are actually doing calculus, and we're working with derivatives. And if you see anything with derivatives, remember this in yellow is your basic equation when you do derivatives. So the first derivative, and please note the difference between this accent over here, which means derivative, versus inverse over there. It's not a typo. It's two very different concepts. So the first derivative of a function gives you the gradient of a tangent. And a tangent is a straight line. So let's see. So now we use this formula and we apply it. So we have a fx equals a half, open bracket, x plus 5, close bracket, squared, minus 8. So we do have a f. But if we want to do a derivative, we can't have brackets. Right? So we need to get rid of the brackets. So we have to multiply this equation and to get it into separate terms. So we leave the half, because remember, when we multiply something out, you do the brackets part first. So the half remains, open bracket, x squared plus 10x plus 25, close bracket, minus 8. So be very much aware of how to multiply two brackets together. So you could have written x plus 5 in brackets and x plus 5 in brackets again, because that is what that 2 means. It means that there are 2 of these. And you can then do the multiplication on the side and you will get to this answer. Now we need to multiply with a half. So a half times x squared gives you a half x squared. A half times 10x, the 2 divides into the 10. It will become 5x. If you're not comfortable, take your calculator and say a half times 10. And you will get 5 for an answer, so it's 5x. And again, take your calculator, a half times 25, and you will get 12,5. And remember the negative 8. So we will use our calculator to add these two together. And then we get, because we did all of this to get the first derivative of the function f. So we apply our rule, and the rule for a derivative is the 2 comes to the front, so it will cancel with that 2 to the n minus 1, so that will become a 1. But in some further lessons, I will explain this in more detail. But the first derivative of this term is x, and the first derivative of this term is 5. So the first derivative of this function is x plus 5. Now we look at hx, which is basically your straight line. But it's basically parallel to the straight line. If you use k, it's parallel to the straight line that we started with. But what we are interested in is the gradient of that line. So we use the hx as is, and all that we need from hx is the coefficient of x, which is the gradient of a straight line. Then we apply this question. The first derivative of function f is x plus 5, and the m equals this 2 over here. And then we just solve for x. X would be negative 3. And to get the y value, we would sub this x into the original function. And we will get an answer of negative 6. So your point of contact would be negative 3, negative 6. There are other ways to answer this question. I picked this solution because it hinges around something that we all know, but we don't necessarily know how to apply it. Right, so that was 4 marks, and we ended with 4.2.6, and we are now done with question 4. Let's have a look at question 5. Now, question 5 has to do with inverse functions. So this paper has got 2 questions on inverse functions. So in question 5, we have a graph. Fx equals 3 to the power negative x. And we have a sketch of it. Have a look at the sketch. The numbers in red were numbers that I added. So the question on the question paper, it would be without the red and without that. But that basically just tells us that is what the function's name is. A is the y-intercept of f, and B is a point of intersection of f and the line y equals 9. So if you paid careful attention to the previous question, there we had a vertical line. Here we have a horizontal line. So the equation of this line will be y equals 9. So the equation of this horizontal line would be y equals 9. So let's go back to the question. The first is write down the coordinates of A. Now, when you have an exponential graph, we always want to know what's happening at x equals 0. So make a big note for yourself. If you work with an exponential graph, we always want to know what happens when x equals 0. So we sub the 0 into the graph. So y equals 3 to the power negative 0, but I left the negative off. And anything to the power 0 is 1. So the coordinates of A will be 0 for x and the 1 that we calculated. Then for 5.2, they want the coordinates of B. And here we have the same concept as in the previous question. If you have a pair of coordinates and you have a function equation, you can substitute. This time we have the y. We substitute the y into the equation and we can calculate the x. So our equation is fx is y equals 3 to the power negative x. So I substituted the 9 into the y's value. And remember, if you have exponents, we work in prime numbers. So whenever you see in algebra exponents, break your numbers into prime numbers. So 9 becomes 3 to the power 2 equals 3 to the power negative x. If the bases are the same, we can get rid of them. So negative x equals 2. So x will be negative 2. So B would be the x value negative 2 and the y value 9. So this is relatively basic, but I trust you guys see that there's a lot of learning and understanding around here. But just study this stuff. Question 5.3. Now they want a domain. Domain means where will we find x values? But here comes the catch. It's the inverse of f. Now we know that the inverse of f, remember originally, f is an exponential equation. Just go back to it. See, f is an exponential. And And the inverse of an exponential function is a log function. Right? So you can either do it the long way around and actually go and get the inverse, but it's pretty difficult to draw a log function. So what I suggest you do is use the properties of an inverse. Now, inverse means that your x and y values swap. So what do we have here? We calculated in the previous questions the coordinates of A, which is 1, 0. If we do the inverse, we basically swap the x and the y around. And I called it A dash. We do the same with point B. Minus 2 semicolon 9. We swap them and we end up with B dash is 9, negative 2. So if we put this on our graph, we will see B is like a little bit obscured down here, but it's down here, 9, negative 2. And if we plot the 0, 1, it's over here. Now comes something again that you need to learn and need to know, is that your log function can only have positive values. So there are plenty questions around this property, that a log function can never be here. It can never have negative values. That is why the graph goes like this and not like over here, because that instinctively we want to draw it like this. And they're asking for the domain, and we can clearly see, and we could have written down this answer immediately, but I try to explain to you the specific property of a log function. So your x values can only be greater than 0. So we will find x values over here. And if you use my previous method, from the graph to the x-axis, from the graph to the, not the x-axis, from the graph to the x-axis, from the graph to the x-axis, from the graph to the x-axis, and on this side, we will be able to do this here, but the y-axis will stop us because the graph cannot cross the y-axis. So our answer is, the domain is x is greater than 0. So a little harmless question, but very important principles that they are testing here. And you will find this in some or other form in every single grade 12 paper. Right. Now they want to know, describe the translation of function f to a new function h using, or it turns into 27 over 3 to the power x. So this is also a mouthful. So if you've studied the functions, each function has got a specific form. I dwelled a lot on the forms of the parabola. Your exponential function is in this form. It's a base to the power of something. So what we need to do, we need to recognize, if we want to know how it was translated or moved, we need to get this into the standard format of an exponential function. So let's start with it. Hx equals 27 over 3 to the power x. And I'm stressing here, it's exponents, so we use prime factors. So 27 becomes 3 to the power 3 times, and what I've done, if you move this to above the line, the sign in front of the x changes. So that is how I got 3 to the power negative x. basic exponent rules. Now we need to massage it because this is not an exponential functions equation. Right. So if our bases are the same, we can add the exponents. So it becomes 3 to the power negative x plus 3. Now, this is still not in standard format. So we need to take the negative out. So it becomes 3 to the power negative x minus 3. Why are we doing this? It's because the shift, we want the shift in the x value. Because by now, they want the translation or the movement. And the translation we will find in the shift of your x value, not the negative x value, the positive x value. That's why we put the negative on the outside. And now we need to know it shifted 3 units. It says negative, but we use the opposite. So hx was translated 3 units to the right. Even though this says negative, we do the opposite. So it actually it has the effect of shifting the graph to the right-hand side. Right, so the answer is simple, but the theory behind it is quite extensive. Question 5.5. Determine the values of x for which hx is less than 1. Now, whenever you see questions like this, like a hx or a fx less than something, first of all, it's an inequality, but a good way to start, because when we look at this, what on earth do they want? So, I pretend I don't know, but this is what they want. So let's write it down. hx less than 1. So write down what they ask. Now you go to your question paper and find hx. And we'll find hx in question 5.4. And it happens to be 27 over 3 to the power x. And we just completed and we said, say, less than 1. Again, we're working with exponents, prime numbers. So I've repeated a little bit of the previous question. So we will do prime numbers, 3 to the power 3 times 3 to the power negative x less than 1. We add it together like in the previous question. So 3 to the power 3 minus x less than, now this you need to know from grade 7. Anything to the power 0 gives you a 1. So we can replace this 1 with a 3 to the power 0. Why are we doing this? We want the bases to be the same, because that is the way that we solve exponential equations. We want to make the bases the same. Once the bases are the same, we can remove them, and we end up with the exponents. 3 minus x is less than 0. Now here's another little catch. We want a positive x. So to turn this into a positive x, we need to divide it by negative 1. And we do it on both sides. But the minute, remember I said, please note it's an inequality. So the minute you divide by a negative 1, the inequality sign changes. So please note, they check this in grade 12, whether you know this, right? So the inequality changes. So x would end up being greater than 3. So see how cleverly they test whether you've picked up all the rules from your previous grades. So let's see how we're doing with time. We've got about 5 minutes left. So I'm going to go into calculus or differentiation. And I'm going to close off by giving you the basic rules here. Now, this question 7.1 is in every single paper. So again, if you are sitting at home and you are practicing, make sure that you can do this very well. First, you need to understand, I've circled here at the top. Again, f dash means it's a first derivative from first principles if fx equals 2x squared minus 1. So your first question in this section will always be from first principles. Look at the number of marks. It's 5 marks. So we cannot just apply the rule and say the answer is 4x. Because that is the answer. Look at the bottom. The answer is 4x. But you're not going to get 5 marks for just that. So first principles basically mean that you need to prove this derivative. And immediately you will go to your information sheet and you will have a look at 1, 2, 3, 4, 5. The 6th formula down on the left-hand side of the information sheet is this formula. The first derivative is the limit where h strives to be 0 of fx plus h minus fx over h. Now, there's a million ways to write this down incorrectly. We forget the h. We forget the limit. We put that equal sign over there, right? So again, no excuse to get it wrong because this formula is on your information sheet. So let's see how it works. Limit basically means that wherever we want a h, to remove the limit or to apply it, we will replace a h with a 0. That's what it means. Now at the top it says we want a fx plus h minus an fx. So I strongly suggest start like this. Write down fx. We need a fx in the formula. And then fx plus h means wherever you find an x in your equation, add a h. So we'll end up having 2 open bracket x plus h in the place of the x in brackets squared minus 1. Because I'm running out of time, I'm just going to leave it that you guys need to multiply this out. See again, here's the second time that they want you to be able to multiply a bracket squared. So the answer in separate terms will be 2x squared plus 4xh plus 2h squared minus 1. So now we fill this in to the equation. So limit, here's your equation. We rewrite limit h strives to be 0. And this fx plus h, we replace with what we calculated here. Minus, that minus over there, minus fx, which happened to be 2x squared minus 1. Please note the brackets, because this negative is going to turn that negative into a plus when we remove the brackets. So that's a common mistake we make. We write it without the brackets, and then we end up having negative 2x squared, negative 1. So if we simplify this, we will get 2x squared plus 4xh plus 2h squared minus 1 minus 2x squared plus 1. Please note. If we simplify this, we will find that the 2x squareds cancel and the negative 1s cancel. So we'll end up having 4xh plus 2h squared over h equals the limit. Now we need to factorize. We take out the 2h, a common factor, 2h. What remains is inside the bracket, 2x plus h over h. And then we have what we do. We can cancel these h's. So we end up having the limit h strives to be 0 of 2, open bracket, 2x plus h. Now here at the end, right at the end, only at the end, we apply the limit. And we sub this h strives to be 0 in there. That is why the h falls away, because we make the h a 0. So we end up with 2 times 2x, and that is 4x, which is the answer we knew right from the outset. But because they said first principles, we needed to follow this whole story to get our 5 marks. Right, that's the end for today. Next week, I will be doing paper 2, and I'll probably do the analytical stuff and some Euclidean geometry. Thank you, and bye-bye.
Sandra, I want to say a big thank you to you once again for taking us through paper 1, and we look forward to next week when we'll continue on, and we'll be looking at paper 2 in our matric revision series. And of course, Sandra Dixon is a BSc in mathematics, grade 8 to 11. And if you would like to get in touch with her, you can email her at sandradixon67@gmail.com. Once again, Sandra, big thank you to you. All the best, and we look forward to next week.
Thank you, and bye-bye.
Thank you so much. Bye. Well, of course, the video will remain up on social media on both the Facebook and YouTube channels, and we are looking forward to you continue to participate. You're welcome during the lives to actually comment if there are any questions you'd like clarified. And yeah, if you've benefited from this, or if you know someone else who might benefit from these sessions, you're welcome to share the videos as much as you can, like and comment. And of course, subscribe to the Voice of the Cape YouTube channel and Facebook page. From myself, Mohammed VOC Peterson, till I speak to you again, inshallah, I bid you wassalamu alaikum wa rahmatullahi wa barakatuh.
Bye.